Hello everyone, I am Saurabh. Welcome to the unit vector. Today we will discuss the previous year questions of class 10 electricity 2024. First question is, so how you would connect three resistors each of resistance 6 ohm so that the combination has a resistance of 9 ohm. So we are given three resistors, each of resistance is 6 ohm. Let us assume that this is our one resistor, then this is another one, and this is our third one. So each of resistance is given by 6 ohm. So these are given 6 ohm. So we need to connect these three resistors to obtain the total resistance of 9 ohm. So let's see how can we get the 9 ohm total resistance by connecting these three resistors. So first, if we join two resistors parallelly, so first we have connect two resistors parallelly. This is our 6 ohm resistors and this is also 6 ohm. And the third one in series, then what will be the total resistance? So as we know, let us assume R1 is equals to 6 ohm. This is, let us assume R1. Then let us assume this is R2, and R2 is equals to 6 ohm, and let us assume this is our R3. So if you see, these two resistors are connected in parallelly. Let us assume the total resistance of the parallel connection is 1 by R double dash is equals to what will become 1 by R1 plus 1 by R2. So from here we can write 1 by R double dash is equals to 1 by R1 means 6 plus 1 by R2 means 6. So from here we will get 1 by R double dash is equals to 2 by 6. So we can write R double dash is equals to 6 by 2. Then our R double dash becomes 3 ohm. Okay, so the total resistance of this parallel connection is 3 ohm. If we redraw this diagram, then it will become, here we find the total resistance of these two resistor, which is 3 ohm. Okay, this is becomes 3 ohm, and this is the another resistance of 6 ohm. So now see, these two resistors are connected in series. So from the series formula, R is equals to R1 plus R2, we get total resistance R is equals to 3 plus 6, which is 9 ohm. So to obtain 9 ohm total resistance, we need to join two resistors in parallelly and the third one in series. Our second question is, in the given circuit, calculate the power consumed in the resistor of 2 ohm. So we need to find the power consumed in the resistor 2 ohm in this resistor. So this is basically a series connection, and we know in series connection current remains constant and potential difference vary. So here we don't know the current which is flowing through the conductor. We know the formula of power is P is equals to VI. So we don't know the I or the current flowing through the conductor, and the V means potential difference across the 2 ohm. So first, if we find the current flowing through the conductor, we need to find the total resistance of the circuit. So we can see here the resistors are connected in series. So here total resistance will be R is equals to 1 plus 2, which is equals to 3 ohm. And here given the potential difference or total potential difference is 6 volt. From here we can find out the current flowing through the conductor by Ohm's law. As we know, I is equals to V by R. So from here we can get V is equals to 6 volt and R is given by 3. So current is 2 ampere. That means 2 ampere current is flowing through the conductor. And now we can find the potential difference across the 2 ohm resistance. So let us assume the potential difference across 2 ohm resistance is V1. So if we find V1, then again V1 will be equals to I. Let us assume this is R1 resistance, IR1. So from here we will get V1 is equals to I means current, which is equals to 2 ampere, and resistance is also 2 ohm. So potential difference will become 4 volt. So we find potential difference and current. Now if we find the power, which is P is equals to VI, then simply put the values of V and I. V is 4 volt and I is 2 ampere. So from here we will get power is equals to 8 watt. Our third question is define electric power. Express it in terms of potential difference and resistance. So what is electric power? The rate of doing work is called electric power. So express it in terms of potential difference and resistance R. Okay, rate of doing work is called electric power. So from here we get P is equals to W by T. Also, we know that V is equals to W by Q. Potential difference is equals to work done divided by charge. So from here, W is equals to VQ. If we put the value of W, which is VQ, in place of W, so we will find VQ by T. So again, see P is equals to V into Q by T. We can write P is equals to V into Q by T. Again, Q by T is also equals to current. So from here we can write P is equals to VI, but we need to express it in terms of potential difference V and resistance. But again, we know that V is equals to IR. From here, I is equals to V by R. So we can put V by R in the place of I. P will become V into V by R. So P will become V square by R. This is the expression for power in terms of potential difference and resistance. An electric oven is designed to work on a main voltage of 220 volt. This oven consumes 11 units of electrical energy in 5 hours. Calculate power rating of the oven, current drawn by the oven, resistance. Okay, what are the given quantities? Given the main voltage of 220 volt, that means potential difference is given by 220 volt. Then this oven consumes 11 units of electrical energy which is equals to work done is given by 11 unit. Remember that 1 unit is equals to 1 kilowatt hour. So 11 unit will become 11 kilowatt hour. So from here, work done we get 11 kilowatt hour, and also time is given by 5 hour. T is equals to 5 hour. As we know, power which is equals to W by T. So from here we can find out the power which will be equals to work done is given by 11 kilowatt hour. Power is given by 11 kilowatt hour and time is given by 5 hour. So here hour will be cancelled, and if we divide 11 with 5, then we will get 2.2 kilowatt, which is equals to 2.2 into 1000 watt. We know 1 kilowatt is equals to 1000 watt. So from here we get power is equals to 2200 watt. So this is the answer of A. Next, current drawn by the oven. Also, we know that P is equals to VI. So we can write I is equals to P by V. If we place the values of P and V, P is given by 2200 watt and potential difference is given by 220 volt. So if we cancel, it will be 10 times. Therefore, I is equals to 10 ampere. This is the answer of B. Again, we need to find the resistance of the oven when it is red hot. Also, we need to find the resistance. If we see P is equals to VI. Again, V is equals to IR. So we can write IR in place of V. So it will become P is equals to I square R. We need to find the resistance. So a resistance R will be equals to P by I square. Power is given by 2200 watt and current is given by 10 ampere. Here I square means 10 square. So we will get 2200 divided by 100. So we will get the resistance of 22 ohm. Alright, the relationship between resistance R and electrical resistivity rho of a material of conductor in the shape of cylinder of length and a area of cross section A, hence derive the SI unit. So we are given a conductor of length L. Let us assume it is a conductor whose length is L and area of cross section means this is given by A. So we need to find the relationship between resistance R and resistivity rho. As we know, resistance is directly proportional to L or length of the conductor, equation number 1, and also resistance is inversely proportional to area of cross section. This is our equation number 2. By combining these two equation 1 and 2, by combining these two equations, we get resistance is inversely proportional to area of cross section and directly proportional to length of the conductor. When we put equal sign in the place of proportionality sign, there comes a constant which is rho, resistivity L by A. This is the relationship between resistance and resistivity. Hence derive the SI unit of resistivity. So now we need to find the unit of resistivity. We find the formula R is equals to rho L by A. By cross multiplying, rho L is equals to RA. So rho will be equals to RA by L. If we put the units of these quantities, we will get the unit of resistivity. The unit of resistance is ohm and unit of area is meter square and also unit of length is meter. So 1 meter will be cancelled. So we will get the unit of resistivity ohm meter. This is the derive of the SI unit of resistivity. Our last question is the resistance of a metal wire of length 3 meter is 6 ohm. If the area of cross section of the wire is 4 into 10 to the power minus 7 meter square, then calculate the electrical resistivity of the wire. So what are the given terms here? Given the length of the wire is 3 meter, so we can write L is equals to 3 meter, and also resistance of the metal is 60 ohm. R is given by 60 ohm and the area of cross section is 4 into 10 to the power minus 7. That means A is given by 4 into 10 to the power minus 7 meter square. Calculate the electrical resistivity of the wire. So we need to find the resistivity means rho. So as we know, R is equals to rho L by A and also rho is equals to RA by L. If we put the values of these terms, resistance is given by 60 ohm into area is given by 4 into 10 to the power minus 7 and length is given by 3 meter. So if we cancel 60 with 3, then we will get 20. So from here we get rho is equals to 20 into 4 into 10 to the power minus 7, which is equals to 80 into 10 to the power minus 7 ohm. meter. So the resistivity of this material is 80 into 10 to the power minus 7 ohm meter. Next, our question number 2 is state how would electrical resistivity be affected if the wire is stretched so that its length is double. Justify your answer. So as we know, resistivity never changes. Resistivity of a material remains constant whether the length is increased or decreased. Here resistivity will remain same. We need to justify our answer. Let us assume this is our case 1 and this is our case 2. Let us assume that at first case length of the conductor is x. X is the length of the conductor and area of cross section is small a. In case 2, the length of the wire is doubled. So length of the wire has become twice x, but area of cross section remains same, which is a. Okay. At first case here length is given by x and area of cross section which is a is given by small a. As we know as we know resistance is directly proportional to L. So if length increased by double then resistance will also increase by double. So in first case let us assume that the resistance of this conductor is smaller. So resistance R is given by smaller. So according to the formula rho is equals to RA by L. Let us assume this in first case resistivity is rho 1 is equals to area of cross section is small a divided by length is x. In first case we find the resistivity Ra by x. But in case 2 length become double. So here L is equals to twice x and area of cross section will remain constant a. And as we know, resistance is directly proportional to length of the conductor. If the length is double, then resistance will also be double. So we can write resistance is equals to twice R. So again by the formula rho 2 it will be equals to Ra by L. So here resistance is given by twice R multiplied by A means small a divided by L which is twice x. Here 2 will be cancelled. So from here we get rho 2 is equals to Ra by x. Again, if we see Ra by x is equals to rho 1. So we can write this is equals to rho 1. In both cases, resistivity is same. So resistivity of a material does not depends on the length of the conductor or the area of cross section of the conductor.